Welcome, star enthusiasts. Have you ever imagined witnessing an astronomical event so monumental that it casts shadows across Earth? Visible to all? This extraordinary scenario might be closer than we think. In the Orion constellation, the star Betelgeuse is displaying unusual behavior, hinting at an impending cosmic event that could light up our sky like never before. But when exactly will Betelgeuse explode, and what will this celestial spectacle look like? According to scientists, this explosion could reveal deep cosmic secrets. Join us as we explore the mysteries surrounding Betelgeuse and the potential effects this event may have not only on Earth but also on the entire solar system. Located approximately 650 light-years away in the Orion constellation, Betelgeuse is not just any ordinary star. It is a red supergiant, one of the most luminous stars we know, shining with a brightness over 100,000 times that of our Sun. But why is this massive star so significant to us? Apart from its brilliance, Betelgeuse holds a deep cultural significance. The name Betelgeuse derives from the Arabic phrase Yad al-Zur, meaning the hand of Orion. This star has been observed and recorded by ancient civilizations for millennia, guiding travelers and fascinating astronomers with its distinctive red hue, setting it apart from other stars in the constellation. Imagine a single star so enormous that it could overshadow our entire solar system. To provide some perspective, if Betelgeuse were to replace our Sun, its outer edges would extend all the way to Jupiter. How does such a star achieve these colossal dimensions? At around 10 million years old, Betelgeuse is much younger than our 5-billion-year-old Sun. However, its immense size leads it to consume fuel at a far quicker rate, forecasting a much shorter lifespan compared to other stars. This celestial giant, occupying a volume large enough to house over 1 billion suns, is nearing the end of its life cycle. When stars of this size reach their twilight years, they don't simply fade away. Instead, they make a dramatic exit in the form of a supernova, an explosive event of unimaginable energy and brilliance. This type of explosion has the potential to outshine entire galaxies, creating shadows of light that stretch across vast cosmic distances. The last time Earth witnessed such a nearby cosmic explosion was in 1604, before the advent of modern telescopes. The Kepler supernova, visible for over a year and a half, was the most recent supernova observed in the Milky Way. It was so bright that it rivaled other stars in the night sky and remained visible even during the daytime for several weeks. So, what hidden truths do these stellar remnants reveal? Ancient records from civilizations, including those of Chinese and European astronomers, documented the appearance of new stars, giving us insights into the violent ends of massive stars. Remnants of these explosions, seen today as expanding clouds of debris, continue to provide us with valuable data about the catastrophic ends of supergiant stars. Although supernovae have been rare for observers on Earth, imagine an event so powerful that it rivals the brightness of the full moon, casting shadows on Earth at night and possibly being visible in daylight as well. The radiation emitted by such an event would be so intense that it could charge our atmosphere, potentially disrupting satellite communications and even affecting the environment. Betelgeuse, with its erratic dimming patterns, seems to be preparing for just such an explosive spectacle. Could we be on the verge of witnessing one of the most extraordinary events in the universe? Just recently, between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that captured the attention of astronomers and stargazers alike. Known as the Great Dimming, this change in the star's brightness, which had been relatively stable for centuries, began to drastically decrease. This sudden dimming was so noticeable that even casual observers could see the change when comparing Betelgeuse with other stars in the Orion constellation. This implies that we may not be centuries away from witnessing Betelgeuse's supernova. It could happen within the next few decades or perhaps even sooner. By April 2023, astronomical observations indicated that Betelgeuse had returned to its normal brightness levels, leading many to believe that the dimming period had ended. In a stunning twist, over the following months, Betelgeuse's luminosity surged by an unexpected 50%. While fluctuations in brightness are common for variable stars, such dramatic shifts in brightness are highly unusual for a star like Betelgeuse, which typically exhibits consistent cycles of luminosity. This abrupt increase in brightness thrust Betelgeuse back into the spotlight, raising questions about what caused this unexpected change. Why did this once predictable star suddenly undergo such dramatic fluctuations? Stars are not simply fixed points of light in the night sky. They are dynamic, evolving entities with life cycles, behaviors, and mysteries of their own. For many stars, changes in brightness occur in predictable patterns, much like the seasons of Earth. Betelgeuse had maintained a relatively steady 400-day luminosity cycle throughout much of its existence. However, with the Great Dimming, it appeared to defy this established pattern, challenging our understanding of stellar phenomena. Now you might be wondering, are we on the brink of an astronomical discovery? While the exact reasons for Betelgeuse's anomalous behavior remain under investigation, an intriguing theory has emerged. This hypothesis involves stellar activity and mass ejection, presenting a fascinating scenario. Imagine Betelgeuse as an enormous volcano quietly emitting vast quantities of its material into space. Previous observations from the Hubble Space Telescope revealed that Betelgeuse had expelled a massive amount of material from its surface into the cosmos. This ejection, a spectacular event, involved roughly 400 billion times the mass typically expelled by similar solar phenomena, equivalent to several times the mass of our Moon. Such events can lead to the formation of a dense cloud of dust around the star, temporarily reducing its apparent brightness and making it harder to observe. As this dust cloud disperses or is pushed away by the force of the star's radiation pressure, the star's true brightness is revealed once again. This could explain why Betelgeuse returned to its normal luminosity levels after the dimming period. These new developments suggest a star that isn't finished astounding us yet. Many speculate that Betelgeuse is approaching the end of its life, but what exactly is a supernova? A supernova is an explosive burst of energy that can outshine an entire galaxy. This event occurs when a star undergoes a sudden collapse at its core, triggered either by the accumulation of matter from a neighboring star or, in Betelgeuse's case, the depletion of its nuclear fuel. As this fuel runs out, the star's mass collapses inward, setting the stage for a cataclysmic breakdown. But what pushes a massive star like Betelgeuse toward this end? Born from the gravitational collapse of gas in atomic clouds, stars like Betelgeuse begin their lives by fusing hydrogen at their cores. This initial stage, known as the main sequence, lasts for billions of years and forms the foundation of a star's life cycle. As hydrogen reserves are exhausted, the star progresses to new stages, beginning with the fusion of helium. In Betelgeuse's case, this transition results in the formation of heavier elements like carbon and oxygen. Eventually, as the helium reserves are depleted, the star expands into a red giant. Over time, as the star's mass increases, it enters stages of even heavier fusion, each step marked by the creation of increasingly complex elements. Eventually, when iron forms at the core, it cannot generate the energy needed to counteract the force of gravity, leading to a collapse and ultimately a massive explosion. The supernova is Betelgeuse's approaching explosive end. Recent research from Japan's Tohoku University suggests that the star may currently be in its carbon-burning stage, and its core could collapse within the next few years. However, not all researchers agree. Studies from Hungary's Konkel Observatory suggest that Betelgeuse is still in the earlier helium-burning stage. Despite these differing opinions, one thing is certain: Betelgeuse is destined to become the next supernova in our Milky Way. But when will this happen? The timing remains an ongoing mystery, with estimates ranging from just a few decades to as far as 100,000 years into the future. While scientists debate the exact timing of Betelgeuse's demise, one undeniable fact remains. When it happens, it will be a truly extraordinary event. As we ponder the potential for such a celestial explosion, it's important to consider the broader implications of such an event on our cosmic neighborhood. When Betelgeuse reaches the end of its life, the shock waves produced by its supernova will impact the surrounding interstellar medium. These shock waves will create vast regions of ionized gas, enriching space with heavier elements formed during the star's lifetime. This process plays a vital role in the ongoing cycle of star formation and planetary creation. Moreover, the light from Betelgeuse's eventual explosion could serve as a natural laboratory for astronomers studying the life and death of massive stars. By examining the light curve and spectral features of the explosion, scientists can gain valuable insights into the physical processes that occur during such destructive events, refining their models of stellar evolution. But beyond the scientific impact, a supernova could have profound social and cultural consequences. Throughout history, celestial events have inspired artists, writers, and philosophers to reflect on our place in the universe. Betelgeuse's eventual explosion could spark a new wave of creative expression, as people across the globe gaze up at the night sky, contemplating the transient nature of existence and the vastness of the cosmos. On a practical level, the radiation from a nearby supernova could have significant effects on our technology. Increased radiation levels might interfere with satellite communications and navigation systems, prompting the development of new technologies to protect and shield us from such effects. In the end, whether we view Betelgeuse's explosion through a scientific lens or from a more philosophical perspective, it serves as a reminder of the fleeting nature of existence. Even the most massive stars eventually reach their end, and their ultimate fate mirrors our own brief yet meaningful moments in the grand expanse of time. As we continue to contemplate the possible supernova of Betelgeuse, it's important to reflect on how such a massive stellar explosion might influence the broader astronomical landscape. The event would not just affect our immediate vicinity in the Milky Way galaxy, but could also have ripple effects that influence the interstellar medium in profound ways. The shock waves from Betelgeuse's supernova would generate massive regions of ionized gas, creating areas of intense radiation and cosmic activity. This ionized gas would enrich the surrounding space with heavier elements, many of which are crucial for the formation of new stars and planets. This enrichment is a vital part of the cosmic cycle of mass matter. Stars like Betelgeuse create and disperse elements such as carbon, oxygen, and even heavier elements that play an essential role in the formation of new stars, planets, and even life itself. In this way, the life and death of massive stars contribute to the very fabric of the universe, fostering the next generation of cosmic bodies. The eventual explosion of Betelgeuse could mark the beginning of a new era of star formation in the Orion constellation and beyond. From a scientific perspective, the light and radiation from a supernova provide astronomers with an incredible opportunity to study the end stages of stellar life. The light curve, essentially the pattern of how a star's light changes over time during a supernova, can give astronomers vital information about the star's mass, age, and internal composition. The spectral features of the explosion, which can be broken down into different wavelengths of light, provide further insight into the elements present in the star and the mechanisms driving its explosive death. By analyzing these factors, scientists can refine their models of stellar evolution, improving our understanding of how stars live and die. Supernovae like Betelgeuse could ultimately help us understand the physical processes at play in the universe's most extreme phenomena. Beyond the immediate scientific advancements, a cosmic explosion of this magnitude would likely have profound cultural implications. Throughout human history, the stars have been a source of inspiration and wonder. The sight of a supernova would undoubtedly captivate people across the world, sparking reflection on humanity's place in the cosmos. The awe that a supernova generates could fuel a renewed interest in astronomy, much like the Renaissance did when scientists and philosophers began to reshape our understanding of the universe. During that period, the heavens were no longer simply a backdrop to human existence, but a place of profound mystery and potential discovery. Similarly, the appearance of Betelgeuse's supernova could spark a new wave of creativity. Artists, writers, and thinkers would undoubtedly draw inspiration from this celestial event, creating works of art that explore the fleeting nature of existence and the vastness of the universe. Literature, music, and visual art could all be influenced by the idea of a massive star reaching the end of its life. Just as the supernova of 1604 inspired works of art and thought, Betelgeuse's eventual explosion could fuel a new era of philosophical and artistic exploration. On a more practical level, the radiation from a nearby supernova could present significant challenges for human technology. As the explosion releases vast amounts of energy, it could potentially interfere with satellite communications and other forms of space-based technology. The increased radiation could even impact the Earth's atmosphere with possible effects on GPS systems, telecommunications, and other technological systems that rely on satellites. These challenges would necessitate the development of new protective technologies and innovations, further driving progress in space exploration and satellite technology. In response to these challenges, space agencies and researchers would need to work on advancing our protective capabilities to shield Earth from the effects of such intense radiation. This may involve the creation of new materials, protective satellites, or even strategies for managing the risks posed by cosmic radiation. As our dependence on technology continues to grow, addressing these issues becomes ever more crucial for ensuring the safety and security of satellite systems and infrastructure. On a deeper level, the impending explosion of Betelgeuse serves as a reminder of the transient nature of the universe. It emphasizes that even the most massive and seemingly indestructible stars are not eternal. Betelgeuse's eventual fate highlights the cyclical nature of the cosmos. Stars are born, they live, and they die, creating and destroying in the process. This awareness of the impermanence of celestial bodies can lead to greater philosophical musings on the nature of time and existence. How does our brief existence as humans compare to the millions or even billions of years that stars like Betelgeuse live? What does it mean to be part of a universe that is constantly changing, where nothing is permanent? As we gaze upon Betelgeuse, whether through a telescope or simply with our eyes, we are reminded that the universe is constantly evolving, and so are we. We can find inspiration in the life cycle of stars, and perhaps, just as Betelgeuse inspires us today, it will continue to fuel the imaginations of future generations as they contemplate the mysteries of the cosmos. As we look toward the future, one thing is certain. The supernova of Betelgeuse will be a cosmic event of unprecedented scale, one that will leave an indelible mark on our collective imagination. Whether it happens in our lifetime or in the distant future, Betelgeuse's eventual explosion is an inevitable event that will continue to captivate astronomers, scientists, and dreamers alike. In the grand scheme of the universe, the death of a star may seem insignificant, but to us, it is a reminder of the grandeur and impermanence of existence, a humbling thought that calls us to appreciate the beauty of the cosmos and our fleeting place within it.